model high-rise buildings, the seismic simulator.
The seismic simulators.
So in this project, this is our middle school earth science project. And so big data visualization, data is huge right now. It's, we have millions of these devices that are collecting data, and all across the world, millions upon millions, and big businesses using that data to develop their business models and to learn all kinds of interesting things about us, and then just make lots of money. But then we also have scientists and engineers that are in the trenches that are also using devices that collect data. I'm a former fisheries biologist, and I have friends that are keeping track of fish populations using some of these data collection devices. I have friends that are stream hydrologists that build their own devices that collect water quality samples and stream flow samples, and they just keep track of it on the app on their phone. So, I mean, that's kind of where it's at right now. If we're not having our kids immersed in data, we're doing them a disservice, right, in terms of where the future is. So with this project, kids actually build a seismograph. And so this is a seismograph made out of everyday materials. We're trying to keep costs down. And so this is just a plastic cup, a spool with a brown magnet on there, and some coiled wire. So when this thing runs across that coiled wire, it sends a voltage reading here, and then we have a seismogram that gets generated on Excel. This is just Excel. There's no third-party software or anything. It's just going as serial data into Excel. This one's not hooked up, but if you shook it a little bit, it might generate a graph that with a small amplitude. If you shook it a lot, then you'd have the larger amplitude of waves. And so you kind of get that cause and effect, input, output, the great NGSS kind of stuff. And so students also learn about how these data collection devices work and the science behind those as they build these things. So there's some really cool learning that's involved just in building it. So once they build this, it's like, okay, so what? These things are collecting data. What does that show us? Well, then we can head over here, and what we've done is we've just copied and pasted 10 years worth of earthquake data from the USGS website. So they have all of these events recorded, and we have the latitudes and longitudes that can then be graphed on a really cool 3D world map. And so this is just, anyone can do this on Excel. You don't need any special software or app or anything. And so if you head over here to Insert and then 3D Map, you can open up a 3D map of the world. It's just that easy. You just click, 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 3 clicks. And now we have this map that is showing where all of those earthquakes, there's over 15,000 earthquakes that are graphed on here. You can start to see this beautiful depiction of the Earth's tectonic plates.
Oh, wow.
Isn't that amazing?
Boy.
So it's pretty incredible. So like we head over here, we can see the ring of fire, over there, Mid-Atlantic Ridge. But then we also see some interesting things about some of the human impact, right? So if you look at areas like this, they are hit just heavily with seismic activity, but those are also very, very heavily populated areas as well, right? And so what are engineers doing to help mitigate for loss of life and loss of infrastructure when these severe seismic impacts hit their area? And in these areas too, they're subject to heavy winds. And so how can you use technology and use the design process to basically, prevent your buildings from being destroyed on a regular basis? And so if you go and start researching some of those buildings in that region, you'll come across a building called the Taipei 101. And so this is a high-rise building. It was the tallest building in the world from 2004 to 2008. But what engineers did was they figured out a way to prevent damage to buildings by incorporating a giant, basically a giant pendulum inside of there, so that when the building starts to shake, that thing will actually offset the shaking and cause it not to shake as much, just using physics, right? So this is, and so many of these buildings right now, they have to build up because there's not enough room to build out. And so these buildings are really tall and subject to forces, and so it's kind of interesting. So what we have right here we have this model right here. This is actually a model of the Taipei 101 out of, just some scrap wood, basically. And so what we're going to do now is we're going to look at the impact of using technology in a model high-rise building and how that can help, mitigate for that damage. And so we have this thing, it's the seismic simulator. It's kind of a simplified version of an earthquake simulator. And we've got, up on top of here, we have one of these adafruit circuit playgrounds. You can just grab off Amazon or from your Fry's electronics store. And we have this thing coded so that it's measuring acceleration in just one direction, like this. And so there's actually a sensor that's inherent in this that will actually measure that acceleration for us if we just put a little code in there. So we can just program it, flash the code to there, and then away we go. So as you can see, when this thing moves like this, then it's visualized on Excel. So we're gonna experience an earthquake here. And if you notice, this does not have a tune mass damper in it right now, so this building might be in trouble. It's gonna be kind of loud. You ready? So right there is the visualization of the shaking that occurs without that technology incorporated. So then, here's where the students have the job of tuning a tune mass damper. And so what they're given is just this wooden dowel with a connector here, and they get a pile of washers and a little rubber grommet, and they start to add washers, take away washers. So they're adding mass or taking away mass. They're experimenting with the height of the pendulum, and the goal is to reduce the amount of damage to this building by comparing it with that original graph. And so they can start to, as they start to experiment with this, they can engage with this technology that's kind of hard to understand, to be honest with you. I mean, it makes, until you actually have your hands on it. So let's see if we can, let's see what it looks like. Let's see what our graph looks like once I've already got it kind of dialed in here, but. So now let's take a look. So we'll save it, click. And so now you can see that that technology had a pretty significant impact, on helping that building not receive as much damage due to that seismic impact. So it's pretty cool. So kids can actually, go in there and run trials. They can save their data, compare their data, and it's just a really fun way to visualize